27,000. About 95% of Paradise was lost. Its smaller neighbors, Concal and Magalia, were all but destroyed. How would you describe this fire? Apocalyptic. Using this new tool, Ken Pimlott, chief of the California Department of Forestry and Fire Protection, showed us how fast the campfire spread. Computerized projections on this 3D map chart the course of the fire. Where did the fire start? Fire started in the community of Polga at about 6.
This is how you calculate the speed of the fire. We're going to take values. An acre is 43,560. We're going to give it a value of 44. That's an error of about 1%. We're going to take a mile, which is 5280, and round it down to 5,000. We're going to assume the wall of fire is 15,000 feet wide, which is almost 3 miles. It's about a 5% error. Then we're going to assume 1 football field per second equals 1 acre. And 80 acres per minute burn, which is not 60 acres. We're just going to assume the 80 acres. Okay? 44,000 times 80 equals 3.52 million. Okay. So we take 80 acres times 60 minutes. We get 4,800 acres an hour. We're going to round up and get 10,000 acres in 2 hours. These are the numbers that the TV set's giving us anyhow. We divide this 15,000 foot long wall. 15 into 3.5 million is going to give us 233,300 square feet, okay, per minute. We check our math by multiplying, and we get a number that's very close to the 3.5 million. Now we're going to assume 4 miles per hour, which is almost 6 feet per second. 15,000 feet of wall at 6 feet per second is 90,000 square feet per second. This is how we're calculating movement. 90,000 square feet per second times 60 equals 5.4 million square feet per hour. That's too high. So we assume 3 miles per hour, a 25% reduction. We make that reduction and we get 4.1 million. All right. So we wanted 3.5 million. So now we've reduced that by another 10%. And we get 3.6 million square feet per minute. Just under 3 miles per hour. 3 miles per hour equals about 4.5 feet per second. Okay? 4 feet per second by 15,000 feet wide. This is your numbers. And at minute 312 is a temperature gauge, not a wind gauge, not a wind graph. These are very serious errors. 200 miles per hour equals 300 feet per second. Well, it wasn't moving linearly that direction. It was consuming square footage. You can't make these kinds of mistakes and stay alive. These are the real numbers. And the winds were 40 miles an hour. Our neighbor was home. That fire came over his place next door to us, and he barely got out. I'm not going to go into what happened to him that day. He said there were 40 mile per hour winds in the early morning. In any case, these are accurate. The number is right around 3 miles per hour that it traveled. And if you take these numbers and multiply them out, you'll see that even if there's an error in here, the math itself is sound. The error wouldn't be in the math. It would just be in certain assumptions made when we calculated this speed. All right. This is truth. You may have come across another video that makes some very serious claims that are unsubstantiated by the real numbers we have available. And you want to look at a wind graph, not a temperature graph. Also, when you're looking at the 60 minutes graphic of the fire moving, it touches down at Dean. This wall you see that's shaped like that, this is Dean up here. Down in here would be where it proceeded this way, is where Pearson is. And down this way here would be Pence. We're just a couple blocks in from Pence. We're less than a mile to the river. This is where it touched down first. So when our neighbor ran, he ran for cause. And that fire, it was fast and hot.